All right, today's topic is persistence and databases and related things. So sometimes when you write applications, you need to store data that's going to last between execution to execution of an application. Sometimes this is configuration data, like for your project. If you're writing scientific applications, you might have whole piles of binary data sets that you need to store and read and process and restore. If it's a small amount of data, like the configuration files, we already saw how to use the reader and writer classes to do that. Okay, and that's fairly straightforward. And if you are running a scientific application with a large binary data set, you can open use the data output stream and data input stream and make up a binary format that fits your application and just write all these data sets out in binary and then read them back in and restore. And although that's tedious, there's nothing new in that. We've seen how to do that. There's one thing that does get to be a little tricky, which you should know how to do, which is, say, sometimes you have a pile of objects, okay? And these objects have instance variables which point to each other, so you essentially have this linked structure of object instances. And what you would like to do is save this structure and restore it. It might be a tree structure that you're saving. It might be, a bunch of linked lists. It might just be some complex thing that you've built up, all right? You can't quite just dump them all, if these were just objects that had basic data types in them. If they just had basic data types, there would be no problem, because you could basically dump all the objects out in some format and read them in. Okay, no problem. The problem comes when you have these pointers, these references. Okay, all of our object variables are references, and they contain pointers to pieces of memory. And you can't just dump those out and then read them back in, because this points to a particular address in memory. And when you read the data for this back off of disk and you rebuild it in memory, the chances that it's going to end up in exactly the same location are almost nil. Okay? So these pointers, these references, do not cleanly persist between program invocations. So you've got to be a little clever when you do this. It's not difficult, but it's tedious. But you should know how to do it. The basic idea is that when you're dumping these things out, you need to turn these array references or these memory pointers into something stable. All right? And essentially, you have to build a dictionary of objects and therefore name all of your objects. You can either do the dictionary as a sort of a hash table and give all these guys names, or you can use, just put them in index them in an array. So each object then has a unique ID associated with it that's global over all the objects, or maybe you could do one dictionary for all the object types, as long as you have a unique thing. So then when you're writing these guys out, okay, whenever you hit an object you have to write out, you first have to put it in the dictionary, give it a unique ID, and then recursively find all of the things it references, put those in the dictionary, and get those unique IDs. And then instead of writing out the pointer, you would write out the unique ID. So that guy would be 2, that guy would be 1. All right, and then this guy, when you wrote it out, would be 3, and so on. So you've written all the stuff out now in this independent format. You have to write out the dictionary so you can remember the mapping of what objects an ID of an object is, or you could build it into the object itself, for that matter. You could have a separate ID field that just remembers its index, so that when you read it in, you can find it. So then you read in these things, and then you have to go through and just relink them. Okay, you have to resolve. When you read them in, you have to build all these data structures, and then do a pass over everything you do, and turn all these indexes back into the new pointers for where these objects reside. Oops. So the good news is, in Java, there's a system to do all this for you. This is what these object streams, I think there's an object input stream, an object output stream. They basically do all this for you. So it's pretty much invisible to you. You might have to implement the serializable interface on it. But once you do, Java will dump and restore object nets for you automatically. Most other languages will not do that. Certainly if you are doing this in C and you have a structure like this you've built up, you've got to do it by hand. So you should know how to do it. But then try not to do it.
How does it deal with if you add variables to an object? Will it read a stream that was written from the previous version of the object?
The Java stuff tries to do versioning. Okay? In general, that's not a happy thing to do. If your data formats lag too far behind your current program formats, then it's going to be a nuisance. And you need to provide some, version number on the file, and then conversion routines back and forth, and all of this. But I think the Java stuff tries to do some of that for you, but you're really treading on the edge if you depend on that stuff. Now, business applications, as we know, require the storage of large amounts of structured data. I mean, that's basically the whole essence of the business or the enterprise software industry is maintaining, businesses just have tons and tons of structured data about employees, about customers, about accounts, about inventory, about vendors, financial information, you name it. And it's all essentially structured data. By structured data, I mean things that look like classes or instances of classes. So you have kind of a type and then basic data fields in the type. Okay? More like C structures than objects, because you don't get to, in general, put methods. It ignores the whole issue of methods and inheritance and stuff. But basically, you have think of them as classes and with instance variables of basic types. So, as people built these databases. Originally, they used structures kind of like this, very ad hoc. And eventually, they came around to, a set of common practices about what works well, and a bunch of companies making standard software that incorporates that. And that is the field of database software. Okay, and most databases today are what's called relational databases. You'll have a course on this and learn more than you ever wanted to know about relational databases. So I just wanted to cover a few of the basics and talk about the Java interface. The basic idea of relational databases is all of your data is in the form of tables, okay, which you can map psychologically or almost directly into the idea of structured data or objects. The columns represent your various slots or instance variables or correspond to them, and they have a name. Say we had a database where we had first name, last name, salary. Say we had some kind of employee database. And each of these has a type associated with them. So this would be a character string. And this is a character string, and this would be a currency value, and that could be a date, so it could be higher date or something like that. Now the rows correspond to particular incarnations, or essentially instances. So if this is an employee table in a database, each row would represent an individual employee, and each column represents the a particular property of that. And so you can see these map pretty closely into our notion of objects, where here each row corresponds to an instance, and each column corresponds to the set of variables in the class. Okay, so it's kind of a close mapping. So that's the basic data model. And databases these days, modern databases, provide kind of 4 functions. One is persistent data storage. The second is convenient access. Okay. Basically, when you have a bunch of objects, you basically write programs to Java programs or C programs to manipulate it. People have found that you always want to talk to the database in pretty much the same way, and there's a certain amount of theory behind these databases, and these are encapsulated in basically database access languages. Okay, we'll talk about that in a second, but let me finish my list. Another thing that these give you is multiple readers and writers. So you can have lots of people connecting and updating the table, and the right thing happens. And finally, robustness to all sorts of failures. So this, we've kind of talked about, and it's not so much a big deal. You can kind of do that yourself. Even these things you could store as flat text files, although they might get very large and inconvenient. Convenient access is not too hard to do. And most relational databases these days have converged on a standard language, mostly through market momentum. And that language, which again you'll hear a lot more later on, is called SQL. I don't believe it officially stands for anything anymore, but it derives from something earlier called structured query language. And this is a language that basically gives you a lot of high-level operations for manipulating tables, querying tables, joining tables, updating tables. Okay, it's a high-level language geared very much towards dealing with database tables. I mean, that's what it does. And it has a whole mess of commands in it. And as I say, you'll see a lot later. So I'll just give you an example. The basic access command is called select. And you give it a series of column names. So say I gave it first name, colon, last name, salary. Okay, select those. From, and then you give it a table name. And then you can give it some conditions where, let's see, first name, and salary is greater than 10,000. And then you end this with a semicolon. Now, if you're sitting at a database console, something that's connected to your employee database, and you type something like that, what it will print out on the screen is something like this, where it has 3 columns, which are the columns you asked for, and then a subset of the rows being only those rows from the bigger table that matches your conditions. So all these guys will, of course, be Sam. All these guys will be greater than 10,000, and that will be undetermined. So once you get into it, there's piles of conditions in the where. There's lots of fooling around you can do here to compute various quantities over the table. There are different commands. There's commands to update. There's commands to query. There's commands to create, all sorts of stuff. But it all basically looks like that. And it all basically processes this model of tables. Now, one thing we can do here in our object model is link to other objects. And we can do sort of equivalent thing in our table model, though a little more, maybe one step removed. Each row, or in each table, there's usually a column which has the property that its value is unique for each row. Okay, so say for employee, it's an employee ID. So once you have that, you can use this as what's called a primary key. It's something that will uniquely identify a row. And then you can have another table, which is maybe, I don't know, departments or something. And one of the columns in this can be employee ID. And these entries are linked directly to these entries. The values that you use here are the same values that you use here. And you can use this language to essentially use that fact that these columns are linked or are meant to be linked. Now, the thing is not going to do any fancy type checking for you. It's not going to let you type this as an employee ID and that as an employee ID. Okay, they're just going to be numbers. So you have to be a little bit careful that you match things up right. But you can, by using a unique identifier in each one of your rows, you can build structures that essentially refer from in one table to entries into another table. And you can get the equivalence of linked structures that way. So, okay, so far so good. This is not terribly difficult, easy, or either. There's a theory behind it, and you can just go and implement the theory. It takes a lot of work. And to optimize these queries takes a lot of work. It's essentially a whole compiler and optimization problem that you have to solve. But you know, you can get some open source programs like MySQL, which will do these two in a decent fashion, at least for a reasonably small database. These two, on the other hand, start to get very difficult. And once you get into multiple readers and writers, all sorts of problems break out. And we saw some of those with multiple threads. Yikes. With multiple threads, in that we needed to synchronize some routines to make sure that some of our operations didn't happen the wrong way or in the wrong order. This problem is immensely multiplied or increased in the database world because you need more powerful primitives than synchronization. Plus, you need an implementation that minimally locks things. So you can't just go and synchronize all access to all of your tables, or your database will crawl with lots of readers and lots of writers. So databases and anything that pretends to be a modern database implements transactions. Okay, transactions are a way of organizing operations in an environment where you have multiple readers and multiple writers. And pretty much you could almost claim that implementing transactions is almost the definition of a modern relational database. And transactions are sequences of operations that certain properties hold over. And there are 4 properties, and they go by the acronym ACID. So if you hear the ACID test in relation to databases, this is what they refer to. Philip, I'm sure, will go on about this endlessly. They are atomicity. Okay, so say we have our banking application. Let's go back to the wonderful question on quiz 2. And we had our transfer, which we decided we had problems synchronizing. But say we want to make that a transaction, and that has withdrawal and then deposit, and that's, you know, account and amount, and that's account and amount. And say we want to make that a transaction. So atomicity says that when we do one of these transactions, okay, we want to do this transfer, it has the property that either it completes, both of those things complete completely, or neither of them do. Okay? That if, you know, something bad happens after with the withdrawal and before the deposit, okay, the system crashes, the network goes down, anything bad at all that prevents this from happening, the world is like this never happened either. Okay, so this is a very important property and difficult to implement, but critical. A critical notion that, if everything goes good, both of them happen. If anything goes wrong in the middle, it's none of them happen. You never get partial completion. Okay, related to that, and that's either an A or an E, and I can never remember which, in English, is consistency. And that means that the database, at every time, every moment, is always going to be a consistent state. And the user is allowed to design rules that specify consistent states. Okay, and this relates to the atomicity. So that, say we have a condition that account balances have to be within a certain range. So if, say, this one succeeds and this one fails, or this one succeeds and this one fails because, this account was closed or something, or not accessible, again, this one, the transaction will be rolled back to the state before the transaction was begun. Okay, so it guarantees you that not only that it will happen or not happen as a unit, but if it does happen, it will result in a consistent state of the database based on any conditions that you've applied. Okay, I is isolation. I sometimes call this independence, but some of you got at this or were worried about this in the quiz. The issue of isolation is that a third party, okay, or a second party, I guess, looking at the database, or all the other people looking at the database, will either see the condition of the database before these two happen, or the condition of the database after these two happen, but nobody, even though it's all going on at the same time, will be able to find a state of the database that occurs halfway between the transaction. Okay, so it's always made, the whole global ensemble is not only consistent, but it's instantaneously updated globally so that the mechanics of these events are isolated from any readers and writers. They see this, everybody else looking sees that whole thing happen as a complete unit. And the final one, the D, is durability. This means that once a transaction happens, and the completion of an atomic transaction is usually referred to as committed. So once a transaction is committed, it's there forever. Okay, and the definition of forever depends on what kind of durability guarantees you want, and essentially how big a disaster you want to plan for. And there could be just local disasters to your building that you want to account for, or regional disasters, to your part of the country. So depending on how much money you want to spend, you can build systems that will give you these properties on, a regional scale, or a building scale, or a global scale, so that nothing short of asteroids will wreck your data. Maybe a little overkill, but who knows?
So how does it work? Can you have many transactions going on at the same time?
Yes. So the trick of building a good database, and why people like Oracle get the big bucks, is that implementing these properties on large databases efficiently so you don't have lots of readers and writers waiting on each other, and implementing durability so it will survive all sorts of catastrophes, floods, fires, crashes, backhoes. It's a very hard thing, and it takes a lot of good architecture and thinking and a lot of careful design that there's no bugs. So Java comes in two ways. One is that people like Oracle are now building in Java into their databases, Java virtual machines. So in that query language, you can get Java extensions, essentially. The second issue is the following. Okay, we're not going to talk about that, but we're going to talk about another problem, which is your application. How do you access this database? We talked about if you have a console, you can walk up to it and type one of those queries and return, and it will print out one of those tables on the screen. This is a fun thing to do, but it is usually what you want to do is write programs that are going to update your tables or query your tables or whatever. Especially if it's the back end of a web application, you have to take the user's query, encode it in a URL, and unpack it, turn it into an SQL query, send it off to the database, get it back, and then present the data to the user. So you need a way to talk to the databases. Now, Java's has something called JDBC, which is Java Database something. I forget what the something is. And this is Java's version, essentially, of something called ODBC, which is the Microsoft version of this idea that lets you connect to a database, which is going to be running on the same machine in a different process or maybe on a different machine, and you don't have to worry about it, and then send queries. So if you think about what you have to do, you first have to, what do you have to do? You have to, first of all, you have to be able to, from your language to the particular database, you have to be able to talk to the database at all. You have your program running in Java. You have some database running over here. You have a network connection between them. You somehow have to establish you have to be able to make this communication work at all. Once you've done that, you have to be able to make individual connections to the database, essentially log in. You have to be able to define statements somehow, those SQL statements. You have to be able to execute them. And you have to control transactions. So you can take multiple statements, and you have to be able to say which ones are transactions, what sequences. And finally, you have to be able to somehow access the results, if there are any, if it's a query. So this is all bundled into what's called the JDBC driver. Okay? For each database, you need to find some library that someone's written or somebody's selling you that is a JDBC driver for that database, and that's something that you link in over here and make sure the database supports over there, and that gets you going. Okay? It's not something that you can necessarily, it's not something that's entirely supplied inside of Java, because if you just get a Java download, it doesn't know what type of database you are connecting to, what operating system, etc. So you need one of these drivers. And I don't have a demo because I don't have any of those, nor do I have a database to set up. Then the rest of these are handled pretty much in the standard Java style. There are classes associated with each one of these. For example, there's a connection class. I forget what it's called, but that you connect to the database and log in. You can send it login information. And once you have a connection, you can then send queries and stuff over it. Now, you can share that connection, which are fairly expensive to set up, over multiple queries or multiple threads or multiple users that want to talk to the same database. There is some kind of statement class, I forget what it's called, that corresponds to SQL statements. Its constructor is typically the text string of the statement that you want to execute, maybe with some variable substitution or something. So you basically create one of these things, and if you have a nice driver, maybe it pre-compiles it or pre-optimizes it or whatever. You haven't executed it yet, you've just created it. Now, once you have these two, you can do all sorts of things. You can say to to this guy, execute this statement, okay, and it'll go do it. You can say execute a bunch of statements and then say commit, which will take the last sequence of things and commit them. It'll complete the transaction. Executing something in general does not commit it, okay? It just kind of queues it up in some transaction that you're building, and not until you say commit does it actually try and do it, or at least tell you that it tried to do it. So these are methods, basically. And finally, analyzing the results. When we did a query, we get back a table that looks like this. And so you've got to be able to get the individual rows out of this thing, query it to see how many columns you have, and then translate all of the column data into the native data type of whatever language you are. And again, there's methods to do this. I think it's called like a result set or something that you get back. And then there's iterator methods to bump down here and get the next row. There are ways of, you can get the individual pieces of data. You can build tables and write them out, all this sort of thing. So there's a lot of detail, but it's done in pretty much the style that you're all familiar with, and so it's a matter of wading through documentation. There's some features that are different between JDBC and JDBC2. I think the result set manipulation functions of JDBC2 are more powerful, and the like. But then again, you have to make sure your driver supports which one your driver supports, etc. So let's see.
Well, what about this interfacing libraries? Are they like free, or you have to?
I guess the answer is it depends. I have not been able to find and install one for free that I've liked, but that just could be from lack of sufficient trying. I think there might be, I know there's a JDBC to ODBC bridge, so if you have a database that talks ODBC, you can install this bridge driver and then connect it to Java, and it'll translate through. I don't know whether that's free available from Sun or Microsoft. There may or may not be, well, I'm sure there is commercially, but there may or may not be free JDBC drivers for, say, Microsoft, whatever the, I think it's Access database is, or for Oracle, or whatever. So that takes a certain amount of searching around, and either that or purchasing. Again, if you get one for free, you're not sure how good it is and how well it's been tested and that sort of thing. So, in some sense, you get what you pay for. Any questions on databases? I want to talk a little bit about a different but related topic.
For measuring these different features, so a metric to analyze system performance with, say, 100 different simultaneous users.
Well, there are certainly benchmarks that you can apply to database systems. I don't know how standard they are. I'm sure that every vendor has their own set of benchmarks on which they perform better than somebody else.
TPC, isn't that the database one they throw around?
Is it?
Millions of transactions a second or something?
Oh. So, yeah, I don't know. I mean, there's, again, lots of metrics, and it depends on the, different vendors have different locking strategies to implement those ACID conditions. And some people basically lock the tables, and that can be dangerous because you can propagate those locks all over the place for a complicated transaction. Some people will actually do rollbacks. Will basically make kind of mini copies of the database, operate on that, and then either update, kind of write that into the main database or not, depending on whether the right thing happens, and keep very complicated rollback logs and the whole which lets you back up to and undo transactions and all sorts of stuff like that. But you'll have a whole course on this, and I'm sure you will know far more than me when you finish, probably far more than you want to.
How do you guarantee durability?
Again,
It is replicated all kinds of
Yes, things like that, replication, across the country and different sites, and then you have to keep everything synced up. But on the other hand, if you want to be robust to a flood or a storm or major electrical outages, and you want your business to keep running, that's what you have to do. Final topic I want to talk about today, which is in some ways related and some different. XML does not really have that much to do with Java, except that there's a lot of kind of buzz and action going on in XML these days in general on the web, and with people implementing XML functionality in Java, and so there's a whole kind of Java and XML thread going on. That's some interesting work going on. The other connection is that, like databases, XML has a natural mapping to our idea of structured data, of instances and of instances with members of a class which have instance variables which are defined by the class that they are members of. Now, the difference between XML and databases and object-oriented programming is in their purpose. Databases is for storing data and doing transactions. Object-oriented programming is for manipulating these things in a program. XML is primarily for the transport and a certain amount of processing of structured data. It's, at least its main goal is to communicate from machine to machine through a common format. So you can think of XML as kind of a standard format for describing structured data. XML looks very much like HTML, and they're both descendants of the same master markup language style called SGML. XML is simpler than full XML, but slightly different in form from HTML. And XML, the other thing to say about XML is it's not really a language. XML is a syntax for defining application-specific subsets of XML. So if you say something is XML, you don't really know very much about it, except that there's lots of angle brackets in it, and that the format is text, and that it adheres to certain conventions. To actually use something, you need to define a sub-dialog of XML. And there's XHTML, which is a variant of HTML that follows the XML conventions. What is there? There's something called MathML, which is a markup language for an XML language for describing mathematical formulas for communication or display in web pages and the like. There's one for doing line graphics. There's something like, I forget what it's called, ChemML or something, for describing molecules used by chemists. There's a bunch of these things. The one I've been working on is called Voice XML, which is to describe dialogues in a HTML-like format. So what are the rules of HTML? Well, they're fairly simple. An HTML document consists of raw text marked up by markup tags, also called elements, just like HTML. And the elements these tags are delimited by angle brackets, and they have a name and a series of, also called a tag, and then a series of attribute value pairs, which are in this syntax. All right. So you give a tag like, I don't know, angle bracket picture, attribute equals angle bracket, maybe the URL that contains the source, width equals the width of the picture, size equals the size of the picture, etc. Very similar to HTML if you've ever looked at it. Some differences are that the value part needs to be present, which it does not in HTML, needs to be quoted, which it does not in HTML. And everything in here is case sensitive, which it is not in HTML. Capital P, angle bracket, capital P for paragraph, and small p are the same. The second difference is that, unlike HTML, okay, we have begin tags and end tags. End tags are angle bracket slash name, and they begin with just angle bracket name. You have these in HTML, but unlike HTML, XML always needs these things to be matched. Wherever you have an open, you have to have a close of the same tag name. And they have to nest in essentially stack order. Okay, so the thing is a well-formed tree. You can't do an open here and then try and close it here, because here you have something that doesn't follow stack order. You have two sections kind of trying to cross. You have to nest them cleanly in stack order.
Why is it called stack order?
It calls stack order or tree order because it follows stack semantics. If you think of open, close as pushes and pops, it works cleanly on a stack. Okay, it follows stack semantics with opens corresponding to push. There's a special syntax, as I said, in between here, in between the open and close, can go just text or more elements with more stuff in them. Okay, you can basically build any tree structure you like here, nesting elements and text and the like. And there is a special syntax which you'll sometimes see for something with no elements, no child elements, nothing in it, just maybe some attributes. Okay, and that has this kind of slash close. And all that means is that's just shorthand for, okay, just to keep you from writing, empty things all the time, they give you this special syntax. No big deal, but confusing if you haven't seen it before. So the idea of these things is you can define your sublanguages and then send particular instances around of sublanguages. So going back to it's easy to see how you would go back to representing either our objects or our table in this sort of format. For example, let's look at our employee. Okay, we would communicate the fact that we had an employee here by having an employee tag, and inside of that it would have properties, first name, I'm going to start to abbreviate here, but last name, I don't know. And if you had a list of these in your file, you might want to define something called employee list, which is just a sequence of these guys. Okay. And always you have to start out with some magic tag that tells the world that this is an XML document and does some other things. But this is kind of a simple XML document. It has one tag that's the kind of root tag, and then a bunch of data inside. Now, to use this, the guy you send it to has to know kind of what format that you're sending this data in. Okay, so you have to communicate what type of XML sublanguage you're using. And XML sublanguages are defined. There's a couple standards for defining XML sublanguages. One of them is to write a DTD, which is document type description, I believe, though nobody really remembers anymore. And this basically is a text file that tells you what are the element types that you can have, what are the tag types, what attributes each one can have, and for any element type, which elements can appear as child elements of them. So for employee, the child elements could be first name, last name, salary, Okay, employee list, it could be employee, and you can say that it's not only, you can say that there's ways to specify whether you want exactly one employee, any number of employee tags, etc. So you basically have this language to describe the types of trees. This XML, since it does follow this nesting property, naturally maps into a tree structure. You can define all that information, and then you have a good subset. You have described the syntax of what your XML sublanguage is. Syntax for MathML or whatever, employee ML. Now what you haven't really done is describe the semantics of it, like what, first name is just an arbitrary string. You haven't really told the guy what it actually means, so it helps to make these mnemonic, but then you have to send some subsidiary document that really explains the semantics. DTDs are, the format of DTDs, unfortunately, is not themselves XML. So you're writing this non-XML document to describe your XML class. DTDs do have lots of angle brackets in them, but and there are text documents with lots of angle brackets, but they're not strictly XML. So there's another format that is XML called schemas that is also used to define XML languages. And XML schemas are XML documents themselves. Yes?
There's a line in your syntax section I didn't understand where you said that angle brackets in XML text must be escaped.
Yes.
So they do not appear as markers.
Right. Well, HTML is, if not complete XML, but equivalently a markup language that's like this, okay? And if you want to put in XML that prints like that like on my page, rather than is interpreted as markup inside the XML, or say you wanted to have some of this text element, say we had some text here, and what you wanted to put in the text is some mathematical formula like a is less than 3, okay? Since this is an angle bracket, and angle brackets are central to the syntax, 9 parsers out of 10 are going to see this angle bracket and say, that's the beginning of a tag, and go crazy. Okay? So there are special kind of escapes which start with ampersand. So you would say ampersand LT semicolon, and that says, I really want the less than character there, not part of my parsing syntax. So, schemas. Okay, so now you've got a file with this stuff in it, and you've got a DTD from somebody, or a schema that tells you what its syntax is. How do you use it in your program? Okay, you want to read this in, manipulate it, format it for the user, or create one of these. And you basically get some XML parsers and libraries with models to do this. And there are 2 standard interfaces, one of which is called SAX, which I forget what it stands for, and one of which is called DOM, which stands for Document Object Model. SAX is a serial model. The idea is the parser parses your document serially and allows you to specify callbacks. Okay, pretty much the equivalent of listeners that we would give to an event system. This is an event-based system, so we need to specify listeners for events. And here the events, instead of being GUI events, are tag recognition events. So every time it hits an open tag or a closed tag, okay, it's going to generate internally the effect of an event. And if you have a callback registered for that, essentially a listener, it's going to call your function. So you can basically build functions that analyze, that process this thing serially, and every time you get an employee open, you make a new employee object, and every time you get a first name open, you copy this data in, and etc. Okay, you can start to build up programs that way. DOM is it's an in-core kind of batch model. What the DOM parser does will read this whole document and build a tree structure a data structure inside, and then give you an interface in the Java sense or general sense to that document. So you can, and the interface basically has the normal tree access commands. So you can do get child, get parent, get next child, get nth child, get number of children, get next sibling, okay, to manipulate around the tree. You can add children and remove children as well. Then for any child, you can get the data associated with it. For example, its tag or its attributes or the text or whatever. So it basically turns your manipulation into a big tree walk, okay? And both of these are W3C standard interfaces and produced by a number of people. If you go to apache.com, you will find some open source versions of each of these with Java bindings as well as with C++ bindings. I find the C++ ones slightly easier to use just because of the way they set it up. The Java one is slightly harder to load and initialize and get started, but once you're started and are actually using the DOM interface, it's pretty much the same. Java is also defined, I believe, something called JDOM, which is a simplified version of DOM. The same idea, reads it in and gives you a tree model, but it's just somewhat simpler to use. It's more Java-centric and somewhat more simpler to use than the DOM specs. And I should put like DOM 1.0 and SAX 1.0, as these are evolving W3C specs. The other place you can go look is w3c.org, and there's tons of documentation on the standard interfaces, on XML, on all sorts of stuff. The ability to take one XML document and transform it into another XML document or another document of arbitrary format. And why do you want to do this? Well, one of the motivations behind XML is to repair a flaw in the concept of HTML. You could say it's a flaw or an oversight or whatever. One of the things that's nice that we've talked about a number of times is to separate the notion of the definition of structure from the notion of presentation, to separate how something is described from how it is shown. Okay? Now, HTML, if you think of it as a document description language, kind of confuses those things all over the place, or at least is not satisfactory in either sense. For a document description language, you would like something that operates on, that lets you tag the parts of a document in terms of documents. And here when I say document, I mean a text document in the word sense. So you'd like to be able to tag chapters and sections and figures and paragraphs and references and footnotes. And all these things are kind of the conceptual units that make up a document. Headings, okay? And you want that level of specification to be independent of how it's rendered and displayed. At least when you're moving it around, because you might want to display it on different devices. It turns out that this separation, is problematic in that authors, if you're authoring a document, you really do want to have fine level control about how it's displayed. But it's best not to combine the structure and the display in two documents. So one of the things that XML tries to do is to separate out the structure description. Okay, so you can conceive of a set of XML tags that describe documents in terms of sessions or sections and chapters and paragraphs and all that. There's a nice standard a lot of people use called DocBook, which is an XML, or the latest version is an XML dialect for describing text documents and books and stuff. I think O'Reilly uses that, actually, for a lot of their stuff. And there's an O'Reilly book about it with, of course, a duck on the cover. So how does XML help us with that? Well, there's other target languages which are actually formatting languages. Okay, so we'd like to take our structured document and convert it into something that has actual formatting information. And there's several schemes for describing the formatting, one of which we use a lot in HTML called CSS for cascading style sheets. And these are essentially ways, all these things are essentially ways of taking a tag and saying how you want to display it. Like you could say, when I have an employee tag, I want to display this in, I want to write the word employee and display it in bold and in, a large font and in red or something like that. So you can associate styles with each one of these tags and perhaps even each tag in context. So you could say, the first name field of an employee I want to show this way. The first name field of a customer I want to show this way. Okay, lots of syntax, but the concept is basically not too difficult. This kind of predates XML and grew up around HTML. There's a XML standard called XSL for like XML style sheet language or something like that, which essentially lets you describe, if not arbitrary, then a powerful set of tree transformations on this. So it basically lets you take an XML document it's a tree, and turn it into another tree, which could be HTML for display, which could be some other display language or whatever. So you can do the same sorts of things you can do here in CSS with XSL, and there is actually associated with XSL their own little display language, which is called XSL::FO for formatting objects, which are things like for setting fonts and paragraphs and stuff like that. The things that you would do in kind of a screen formatting language is this. So you would think of the goal of this as you start out with an XML document, and this is also produces XML. So one scheme is you take that, and then you take your XSL style sheet, and you run it through something which is called XSLT, which is XSL transformer. So it takes this and it takes this, and it will produce another XML document, and in this case it would be in this format XSLT::FO. Okay, that's one way to do it. You could make a different style sheet that its output is an HTML document. Okay, you can do arbitrary stuff with this. When I first started to do this course, back when I had more time, I started to sketch out the syllabus and all the lecture notes and everything in XML format. So I actually have an XML file that describes the lectures and what's happening on every day and all this. And then I wrote, and this is what happens when you spend too much time on technology than actual content. So then I wrote an XSL style sheet, which took that description document and run it through XSLT and produced an HTML document, which is the thing that you see on the website today. So to be honest, this probably took me about 5 times longer than simply writing up the XML document to do it. But on the other hand, it's much cooler because I could change this document and reformat that whole thing in a variety of different ways. And plus, it was a good learning experience. Because from Apache, again, you can get one of these in both C++ and Java, and an embeddable library of this, so that you can actually embed the XSLT processor in your code, and then use the parser to read in an XML document, run that tree, and read in one of these, run those 2 trees through this, all in library form, so you don't have to do it at command line, and basically write high-level Java programs to manipulate all of these things. Very powerful stuff. One of the other cool things about this is since all of the inputs and outputs of this process are XML, you can pipeline these things or recycle these things. So you could have, one initial XML document that comes right from the database, and then one style sheet that reformats that into still a data description format, not presentation, but maybe simplified or reorganized or computation done on it. For example, you take a document description and maybe you want to compute table of contents and compute list of figures, okay? So you can do that maybe with one of these XLT processors that makes a new XML document that you can then run through further pipes to refine, and then finally run it through a transform into some display language, either HTML for screen, maybe you want another one that produces PDF for printable form, or TeX for techable form. And so this is very powerful. And there's even a web server, or kind of a web application server now called Cocoon, which is also being developed open source at Apache in Java, which is a web publishing system that's built around this model of multiple XSL transformations on your basic XML document, with finally a publishing transformation which dumps it to either PDF format or HTML format or whatever. So if you want to fool around with this stuff or learn more about it, the best places to go, I think, are W3C for the specs, Apache, lots of interesting Java work going on there. And of course, there's lots of books on XML, XSL, XSLT, CSS, DocBook. There's something called XML in Java, which basically goes into more detail on all the things I talked about, tells you how to set up Cocoon and run one of these things. And it's basically the second half of this lecture turned into a book. So questions?
Could you just talk about that you've got a tree on each side?
Mhm.
And the nodes in those two trees are completely different?
They are the tree here and here. Yeah,
Right.
they're probably not completely different, but they can be different, right? Because this XSL thing can say, okay, when I have an employee node, replace it in this tree over here. Eliminate all of its subparts and replace it with just some employee ID text or something.
But
Okay.
you start with the basic tree structure on the
Yes,
input
you start
side.
with the input side, and when you write this thing is an XML document that describes a bunch of transformations. You can look up there's a nice book. I like the book called, if you're interested in XML, there's something called the XML Companion, which is not so much a how to use XML in any particular programming construct, but really a nice overview of all the concepts. And I particularly like that book if you want to learn a lot of stuff without getting overwhelmed with a particular instantiation. So yes, you write out some rules, and the rules have to know about what the format it expects in and what it can dump out, and then it just does it.
So it seems like this functionality is almost like a scripting language, or? Like
It is, but it's very specific scripting language. That this stuff is a language that transforms one set of type of tree into another type of tree, XML-oriented trees. So it's really a tree transformation language is probably the best way to think about it.
It seems as though one of the functions of this might be machine-to-machine kind of
Yes.
talking. You're talking a lot in terms there of how you could
Finally display it to the user, right.
present in different formats.
Right, but the nice thing about here is, you get it, it's easy to see how you take your query from the database and turn it into this, right?
Yeah.
Okay, and then this you ship from the database machine or whatever to the machine you want to talk to, and then the machine you want to talk to has a program which parses that using DOM and then feeds it into the actual processing, or, if it's a web thing, probably formats it.
Right. So in database compatibility terms, the developers on each end would only need to make sure that whatever system had been implemented, they could read and write the same
Right.
format of XML.
You can kind of think of it from a query point of view as a bit of a substitute for that JDBC, which is talking to the database at a much lower level. Now, it's a little bit harder, you don't get that low-level control, so you probably wouldn't get transactions necessarily. But for queries, it's nice, and it also lets machines to machines talk without having to send around HTML, displayable HTML, because a lot of times, when you want to get data from another web server, you have to get their HTML page, then grovel over all the stuff that's meant to display it nicely to the user and show ads and stuff to find the 3 pieces of information you want, which you then extract and display. And if you had an XML interface to that web server, you could say, just give me the data in XML, and it saves you a lot of screen scraping, which is a royal nuisance. And then again, that's another benefit of separating data description and display. So lots of buzz around XML. It hasn't, it's just starting to really be used and penetrate, but a lot of exciting work going on. It's not quite clear how it's all going to shake out, but it's a fast-moving business. So.
But I thought if you want to display something on your website from the database, you'll use some kind of scripting language, and you wouldn't use XML?
Well, it depends on whose database it is, right? You could have, the database could not be your database, but could be some content supplier who you were buying data from, right? Could be a whole different company who, was basically, you were renting a data feed from, say, some stock quote server. You probably don't have direct access to NASDAQ or something on your little web server. So this basically gives you a way to communicate with some network content server and that you're probably subscribing from, get data from them in a format that everybody can agree on. Okay, so it's most useful when you don't actually own the database that you're trying to access, but that's remote or somebody else. So, any other questions? As I say, lots of literature on this, lots of free stuff to play with, lots of books. Enjoy.